In this demo, we will use Qeexo AutoML to build several machine learning models in under 5 minutes using a sensor tile.box from STMicro. Let's start with collecting some gesture data for our demo project. First, we create an environment, MV Lounge. Then we select the sensors from the list supported by the sensor module and set their sampling rates and full-scale ranges. With one click, we flash this customized data collection application to our sensor tile.box. We will play the drums for our first gesture and record this gesture continuously for 20 seconds. Here you see our model holding the sensor tile.box in his right hand. Motion data is being collected by the accelerometer and gyroscope previously selected. Qeexo AutoML also has an option to upload CSV data or data via REST API. For our second gesture, we will play the violin for 20 seconds. As you may know, 20 seconds of data for each gesture is a very small sample set for training machine learning models. However, we find that this is sufficient for our simple two-class gesture recognition problem. In addition to these two classes, we have also recorded 100 seconds of baseline data earlier that we labeled as no gesture. From the training page, we select the previously recorded no gesture data and the drums and violin data that we've just collected to start a new training. Here is a list of algorithms that Qeexo AutoML currently supports, including ANN, CNN, GBM, logistic regression, random forest, and XGBoost. In the interest of time, we will select these 3 non-deep learning models. Let's leave training running in the background and go visualize our data. This is a accelerometer signal on the X, Y, and Z axis for our drums gesture. We can also look at the gyroscope data. Now let's see what the violin data looks like. You can also zoom in on each of the plots to study your data in more detail. Next, let's see if the model training has finished. Here you will see the live progress of all the machine learning stages for each of the selected algorithms, including featureization, model validation, building classifier, generating learning curves and reports, and calculating latency. Once it's complete, click on Training Results to see the models we built. Here we show the performance in the cross-validation column, the latency for each inference, the size of the models, and more details, including the learning curve, the ROC curve, the confusion matrix, and the MCC matrix. Now let's pick the best performing model to push to the device for live testing. Here you can see the logistic regression model performing very well.